और बोलूंगा।
Hello everyone. So this will be a quick demo on Virtuoso. So we will be making the schematic for the inverter and then doing some basic simulations. So first of all, in your MOVA, we have to go to the CMOS65 library. So and now you can just invoke your Virtuoso from here. The command will be this, and then just write Virtuoso ampersand. Okay, so now we need to make a new library. So your library, you can make all your cells. So I will be making a library here and then attach a existing library. So we are going to use the CMOS 65, which is a 65 nanometer technology. So here you can see we have successfully created your library. So go to files, then a cell. So please select your library that you have already created. So in my case, it's INV lib, and the cell is going to be the inverter. And we are going to make a schematic first. Okay, so this is schematic. So this is your workspace, and we will be making the layout here. So click on I. I stands for your instance, browse, and your library is going to be the CMOS 65. And the cell is going to be the NSVTLP, which stands for the NMOS. These are the parameters for the NMOS, the width, the length, number of fingers. We will discussing this also, and other parameters are here also. So just hide this and just place the instance. You can see this yellow color instance. When you just click, it will be like this. Okay. So for NMOS, it's NSVTLP, and for PMOS, it is going to be PSVTLP. Okay. So I'm going to increase the width of the PMOS to 0.27 micrometers. Place it in. Okay. So please make sure about the orientation of your device. The drain. I've placed the drain like this, so I can just connect it like this. Then connect the gates. Okay. So for instance, you can just click on I, and to make a wire, you can click on W. So you can see your cursor will change in both of the instances. So click on W so for wire, and for your instance, you can click on I. And for escaping from both of the options, you can just press on escape. Okay. So, okay. Now we will connect the pins. For pins, just click on P. So the pins are going to be your VDD, which is the input type pin. Then your ground. input output, your in, which is a input pin, then your output pin also, uh, output. So please make sure the directions are correct. Otherwise, you won't be able to give the stimuli properly. I will repeat this again. W for your wire and I for your instance. P for your pins. And please make sure that you connect the body also. For PMOS, your body is at VDD. And for NMOS, your body is at ground. Okay. So I guess this completes your design. So go to save, and if no error comes, then you are all good. So in case that you have any floating nodes, like let me just demonstrate that. If you have any floating node, like the output is not connected anywhere, right? If I try to say this now, so I will get this warning and this yellow color popping up. So you can just connect this again. Okay. So now let's just save this. So if no warning comes, then you are all good to go. Now we can proceed with the stimuli. So go to launch and ADL. So ADL is basically a platform through which we can perform stimuli, simulations. So I'm going to go for a transient analysis. 10 nanosecond, I guess, is good. Uh, Enabled, apply. Okay. So as you can see, here is the analysis type. Here you can change the temperature like 125 or 27 degrees, whatever you want. Then the corners. So the corners are basically the process on which our devices are going to work, like your fast NMOS, fast PMOS, slow NMOS, slow PMOS. So you can choose the corners from here, corners, and I'm going to go with the typical corner for right now. Apply this and okay. Okay, so now we need to plot the input output waveforms. So what we are going to do is that go to outputs to be plotted, select on design and click on your design output wire and the input wire. So you can see the color also change and it will appear here also. Okay. So please make sure that you have selected the right pins. Okay, so I will repeat this process again. The type of analysis that you want to do, like DC analysis, AC analysis, other options are also available. Then your process corners. Your corners are present here. Your corners and all the corners are here. Okay. And you can also change the temperature. So click on the green button now. Oh, wait a minute. I have not given the stimuli. So sorry for that. You have to give the stimuli also. So go ahead. Then give the ground as a DC 0 volts. This is input. I'm sorry. This is input. So you have to give input as pulse. So the lower voltage is 0 volts. The upper voltage, I'm taking 1.2 volts. Uh, Time period, I'm going to give 1 nanosecond. Delay, I'm going to give 100 picoseconds. Rise time, I'm going to give 10 pico. Fall time at 10 pico. And pulse width, let's just give 500 picos. Okay. So ground, we can make the ground as a DC 0. Apply this. And VDD, we can give a DC 1.2 volts. Okay, so now I guess we are good to go. Let's just click on the green button. Okay, so now you can see your waveforms. So we will just split this like this. So this is your input and this is your output. So you can just analyze the rise fall by clicking on V. So it will give you a cursor to be placed. So this will give you basically the time versus voltage. At what time you can see the voltage. Like here you can see the time and here you can see the voltages. And you can place multiple cursors. Just click on V like this. Okay. So just and you can zoom in and zoom out using this option. You can change the scale basically from this. You can place the cursors like this and measure the output. To overlap these waveforms, you can just drag and drop. Okay. So this is the behavior of your inverter. So now you can just play around with the tool. You can select different corners like slow, slow, fast, fast, typical, typical, any corner that you want. You can change the temperature also. Like go to the lowest temperature like -40, go to 125 and see how the delays are changing. And you can also do the DC and the AC analysis. Also, you can make a schematic for other gates, like your NAND gate, your AND gate. Uh, in those types of gates, only the number of inputs are changing. Rest, you can just give the stimuli as your uh, DC input or your pulse input. You can give any kind of input that you want. Okay, so just play around with the tool and get familiarized with the tool. In the next session, we would probably make the layout of the inverter and do some Endo simulations. That's all. Thank you.